we start from a little bit of revision of last class. Whatever we had concluded, we concluded so far in this way. Work W is defined as force multiplied by displacement. Okay, force multiplied by displacement. We understood this. We understood this in more deeper terms where we said work is the dot product of force and displacement vector. Okay, force and displacement vector, and this will actually boil down to magnitude of F multiplied by magnitude of S into cos of the theta of the angle between the F vector and the S vector. Okay, this is work. And the SI unit of work is said to be joule. Okay, joule. And 1 joule of work is done when a force of 1 Newton moves a body 1 meter along the direction of force. Along direction of force. This much we have learned. We have still, and we also said that cos theta, if you have a right angle triangle, if you have any right angle triangle, let's say this time I'm deliberately making this as theta. Okay, A, B, C. So what was our formula? So ka means, so this becomes my opposite side. Hypotenuse always remains at hypotenuse, and this becomes my adjacent side. So cos theta will always be equal to adjacent side, ka, adjacent side by hypotenuse, so which is equal to AC upon AB. Okay? This is what we had learned. Our entire discussion stopped where we were discussing about that toy wala example. So we go back to that toy wala example once again. Okay? So we now know what is the definition and all. So we take that toy example once again and we will be debating on that. Right. So let's see. Right. Is the door properly shut?
Looks like it.
Yeah, it looks like it is. Still, I think it is. Yeah, it is. Okay, so this is the force. Okay, and if you observe, the displacement of the toy is happening in this direction. There was where our debate, and we had stopped here actually. Okay, and this is the angle theta, right? The displacement is actually this was Zoe, so we remember this is. So this is S vector. Now the question arises, work is always said to be done when the point of application of force. So let's say which is our point of application of force? Our point of application of force is this. Okay, and this should move along the direction of the applied force. Now the force is being applied in this direction, however the toy moves in the straight direction. So we said that is work being done? Yes, work is being done. Now the question arises that whenever work is done, the displacement is along the direction of force. Our question was, either the toy should have moved in this direction, which is not happening. Toy is moving in this direction. That means we can justify work if we have some force in this direction. होना ही पड़ेगा ऐसा. ठीक है? Again, park this story here. Let's go to another story, and that story is called resolution of a vector. Okay, resolution of a vector. This is something again you'll study deeply in grade 11, but now try and understand what is resolution of a vector. Okay, अच्छा उसमें आ गया ना जगह है resolution of a vector. So let's take any vector A. पहले समझो resolution of a vector क्या है. Let us say we have a vector and this is a vector A. Resolution of a vector means a vector can always be broken down into two components. Vector resolution, or many people also call it as resolving a vector. Resolving a vector. First understand, you forget now the toy story completely. If you understand this, you will understand the toy story. कम बढ़िया समझ में आएगा. Okay, we say that a vector can always be resolved into two components. One component is along the horizontal direction and another component is along the y direction. Now what it is, we'll understand. Okay, this is called the one on the a horizontal. This is also a vector, and this is called a vertical. This is also a vector. Matlab,
So it can be either upwards or downwards.
it can only be in this way. Basically, the idea is that this a vector will actually form the diagonal of the imaginary parallelogram, or in your case, this case is the imaginary rectangle. समझ में आया? ऐसा ये है. अब इसको समझेंगे पहले, ये है क्या, ये ऐसा क्यों किया. Okay, let's try and understand. Again, we go back to our same example. Suppose, and pay attention, then only you will understand. Suppose there is a body out here. You drag this body with a force this side, and you drag this body with a force this side. Which side do you expect the body to move?
Like it flip.
हाँ, सीधा आएगा, वो straight आएगा body, वो straight आएगा.
But if one is applying more force than S.
हाँ, थोड़ा थोड़ा सा होगा. So ultimately, what we are trying to say is that this force is the outcome of these two forces. The first basic thing try to understand. This force is the outcome of these two forces. Are you understanding? In the language of vector, we say that if this is a vector A and if this is a vector B, then this one will be a vector C, and C is said to be the vector sum. Now this is, if suppose magnitude of this is 3 and this is 5, don't make it 8 out here. This is not algebraic sum. This is vector sum. This is vector sum. This is something like, आप सोचो psychological जैसा है, मतलब इन दोनों का resultant है ये. A paratrooper falls down. How is the force? वो कैसे जा रहा है? नीचे जा रहा है. आप जीन्स खोलते वक्त ऐसे खींच देते हैं तो जिपर कैसे आ जाता है? नीचे आ जाता है. कपड़े जब फाड़ते हैं ऐसे खींचते हैं, क्लॉथ स्ट्रेट टेयर होता है. समझ में आ रहा है? इसका मतलब है whenever you see one force, let's see any one force that we see, we can actually think that you are actually seeing one type of force. Say suppose I push Zoe now, one force, she goes that way. Is it that she will go in that direction only because of this one force? May not be. If two forces are also adjusted in such a way, then also we can make her go that way. Is this thing clicking in your head? So what we say, we now break this A and say, look, this A is nothing but the resultant of this vertical and this horizontal. अगर किसी को आप इस तरफ जोर से जरा सोचो, common sense लगाओ. Let's say this is 7 and let's say this is 2. Both are being pulled. Who will play more of the role? The 7 will play the more role, but the 2 will also have some impact. 2 is going to lift you upward, and 7 is going to give you in this direction. So you don't expect that you will go this year, neither you will go this year, but आप दोनों को balance करके चलोगे. Now let me give let's say another example. Let me take a pipe. एक pipe लेते हैं. Let me take a pipe, and I roll the pipe on the floor. It just rolls straight away, right? The moment I roll it, I put one table tennis ball inside the pipe. ठीक है? Ball can roll inside the pipe, and pipe can roll on the floor. बड़ा मजेदार चीज है. Pipe can roll on the floor, ball can roll inside the pipe. So it's again, Zoe को बिठा दिया, and I say, Zoe, at 1, 2, 3, I'll roll this way. You just push the ball. So we do it together in synchronize. Tuck. And the moment, so we are doing something like this. So we have a pipe, right? And there is a tennis ball out here, okay? Table tennis ball. I start rolling it this way, and Zoe pushes it this way. Now obviously the pipe is going to roll somewhere here. What do you think is going to happen? The ball will slowly travel till this side. Rolling, and it will come this side. It will roll and come this side. You don't expect the ball to be here. समझ में आ रहा है? So when you resolve a vector into two components, you basically are trying to find out a scenario that, look, don't think only A is there. Any vector can be broken into two components, one along the horizontal direction and one along the vertical direction. And then we say that, look, this A vector is basically the resultant of the horizontal of A plus the vertical of A. This is vector sum. You did not understand vector sum now at this level. But when we break up a vector, we can break it up into two components. Kahin bhi, you are saying, acha, tell me one thing. Let's say Shaurya is there. I push you from behind. Vivan also pushes you from behind in the same direction. We can have two type of diagrams. One is my push of 5, Vivan's push of t. 2 arrows. We can also have one diagram where we will show exactly one arrow of 8 Newton. Combining both. आप जो देख रहे हो ऐसा कुछ नहीं है कि वो एक ही फोर्स है, शायद वो दो फोर्सों से भी हो सकता है. And in vectors, whenever such a scenario arises, we have that trump card in our hand. We can use and resolve the vector into two components. And when these two components are there, please do not consider this component at all. एक ही तो बात है ना, या तो ये ड्रॉ करो और ड्रॉ 1a vector. It's same. Mummy and daddy pulling together the kid, or you think that one person is pulling the kid and he is pulling it in such a way that he is honoring mother's pull and father's pull together. Are you understanding?
Yeah.
Out here also we see one force, but our heart is not agreeing to it because we see the body is moving in this direction. So a question arises, can we now resolve? This is a vector. So as per this law, we should be able to resolve this vector also. ठीक है? तो इस वेक्टर को रिजॉल्व करने की कोशिश करते हैं. देखो, ठीक है? So let's resolve this vector now, and we would say that, and it should be actually exactly like a rectangle. Okay? The diagonal is actually your resultant. I'll say this. This is one force. And this is one force. I call it F horizontal. I call it F vertical. Right now, please take it out from your mind that Zoe is pulling the toy. Zoe and one more Zoe are pulling the toy. One is pulling it in this direction and one is pulling it that way. That is exactly same as one Zoe pulling it in this manner. Is this now clear slowly? Is this getting clear?
So instead of drawing that one force, we could have
so this one force, but silently actually there are two forces. Now our question comes, work is said to be done when the displacement happens along the direction of force. जम रहा है ना, एक force आ गया अभी. One force has come. Right? This force has come. So in this case, if I am asked to define work, I would say work is FH into the displacement S, whatever it is, or say FH vector into the S vector, dot S vector. Are you understanding now? I am supposed to take that force which is the reason.
Multiple forces, but this one has to.
No, ultimately in any scenario when you see a particular force, we have the freedom to resolve the force into two components. Are you getting it? You can resolve it. Look, see. Okay, can you do it? Let's say like this. This is a force. It need not be that you are always making it horizontal. I can make this force like this also. I'll not make it horizontal. It's still the same. Between these two components, there has to be a 90 degree. अभी भी तो rectangle बन रहा है ना? Is it not forming the rectangle? And my axis of analysis is like this now. This is my x-axis. This is my y-axis. Are you able to understand? We'll see a lot of these examples. Don't worry, because this is just the start. You will have a lot of questions. Now, our first thing was to come to a scenario where we actually would try to assign a force so that we are able to justify this diagram. Let me make this diagram once again. Okay, so this diagram is something like this now. Okay. And if you understand this, half of your trouble in grade 11 will go away. But it's not so rocket science also. Okay? This is the original F. This is the original F. Got it? We resolved it into two components right now. We have named this as F vertical and F horizontal. Okay? In such a way Vertical and horizontal will always have 90 degree between them, right? And don't forget the displacement vector, which is also there, the same scenario, and the displacement vector is out here along with this. Let's say this is the displacement vector. This is displacement. इतना चीज समझ में आया, right? And when we make this, we say this is actually the resultant. The original f is the vector sum of the vertical plus the horizontal. Sorry, Sanvi, I'll make it bigger, but I have no other option to write it in this way. And let me say that there is an angle theta again between the displacement vector and the original one. देखो ये, right? Now let's see from 2-3 different angles, and now you'll get the best pleasure. What did we say is work? In high end, I told you work is defined to be F dot S. And how is F dot S solved? F dot S means F modulus S modulus cosine of theta. Let us make it as F of, okay. Whenever you take a vector, children, whenever you take a vector and you take the modulus of it, you can write it as F. No need to put the arrow because we are only dealing with the value right now. Is this much understood? This one understood? We're just dealing with the value. This makes your job a little bit easier. Okay, so now I write F as F. I bring the cos theta here deliberately and I keep the S here. ठीक है? ये है, अब फिगर पे चलो. Let me say this is A, this is B, this is C. Look at triangle ABC. Is it a right angle triangle?
Yes.
ACB. Is it a right angle triangle?
Yeah.
Yes, it's a right angle triangle. ठीक है? Look at theta. What is my opposite side here?
AC.
AC. Hypotenuse is hypotenuse. So this is my opposite side. This is my adjacent side. And this is my hypotenuse. Let us try to find out the value of cos theta here. Cos theta means ka. Adjacent side. What is adjacent side? BC.
Yeah, BC.
Divided by AB. ठीक है? What is the value of BC? Sir, the value of BC is nothing but FH. FH. So FH. Don't forget, don't bring S here. We're just seeing the triangle for the force diagram. Okay, it's just FH. What is the value of AB? F. So what is the value of FH equal to? F cos theta. इसको ध्यान दो और इसको ध्यान दो तो कुछ समझ में आया? Work done will always take that force if you use this formula, which is along the direction of displacement. What is Fs cos theta? Can I not write it as Fh into S based on this? Now you go to your diagram and start questioning yourself. Because in our diagram now, Zoe has disappeared. There is no more Zoe. Okay. Now this is the force and this is the displacement. Fh into S. If you want to keep this force, then please use the theta also. Multiplying by cos theta automatically gives you this. ये समझ में आया? और करेंगे, डोंट वरी. ये वाले को जरा पता करते हैं तो ये कितना होता है. ऐसे सब प्रॉब्लम में होगा. What is this? Isn't this fellow equal to this fellow? Yes. Take the sine ratio here. Sine theta. Sine means so. Sine means so. So sine theta should be equal to what? Opposite side AC divided by AB. So this is equal to FV divided by F. Therefore, FV is known as F sine theta. That means, given any vector A, we can always resolve A into two components. One is A horizontal, which will always be A cos theta. This being, जहाँ theta है, उसका पास वाला cos theta होता है. जहाँ theta है, उसका पास वाला. And this is A sin theta. The vector sum of A sin theta and cos theta gives me A. We'll revise once again, don't worry. Okay, from where did we start? We started that a child pulls, and if you are clear with this, all the definitions will come correct now. Are you just okay with this definition? Work is said to be the scalar product of force and displacement. Fine?
Yes.
Okay. After that, we brought a scenario. Now I'll rub everything and we'll do again. Okay, we'll do again and let's start and see. अब rub करते हैं. I'll rub everything and let's do from here. यहाँ से करेंगे. इसको जितना देर तक आप नहीं समझेंगे, मैं उतना देर तक समझाऊंगा. But you cannot have any doubt when you leave today. Okay, right. Modulus means value. A vector can have a plus or a minus. Modulus means only the magnitude. Like the other day, absolute value. For example, like say, the other day I gave that example. Neha moves to my left with a velocity of 2. So I've taken her velocity as -2. And you move on right side with a velocity of 2. Your velocity is +2. But the absolute, that does not mean she is going slowly. She is just going opposite to our direction of positive. Both of you are going at the same speed. So the absolute value, mod of the velocity modulus will be 2. But if we tell you as a vector, then in vector में हम क्या बोलते हैं? Magnitude बोलो, sir 2. Direction बोलो, okay, Neha -2 and Amulya +2. ठीक है? So we come back to our scenario once again and try and understand, children. Once again, this is a horizontal plane. Let's understand first the vector resolution. Okay, this is a horizontal plane. Okay, let me not do it this way also. Let me do it this way. First, let us understand how to resolve vectors. Suppose I have a vector in this manner. I have a vector in this manner. And the best way to understand vectors are forces. Force is the easiest to understand a vector. This is a force which is acting on this particle P. Itna samajh mein aaya? You are seeing one force. Physics gives you the privilege to always see it in terms of two forces. Mind you, you can make those two forces in whatever manner you want, but they should be perpendicular to each other. Okay? So, for one beauty purpose, I'm just changing the direction once again, because otherwise what I want to do, I'll not be able to show you. So this is my force. Neha, just be careful whether water is coming on that side. Usually water aa jata hai usme. If the water comes, just close the glass one. Okay. This is P. You can feel it. Just touch the parapet portion. Top one. Wet. बंद कर, swelling हो जाता है वहाँ पे. Just close that. Right, fine. Not here. Okay. Look at here. We can resolve it into two components. Now look at my drafter. That's why I did it. Okay. The two components to this force are this. One horizontal and one vertical. I can change them whatever way I want. But these two should always be
Perpendicular to each other.
perpendicular to each other. समझ में आ रहा है?
Okay.
The impact will be same. Let us see some more scenarios of mechanics.
So it can't be you take the vertical.
एक और scenario देखते हैं. Let's say an inclined plane. You know what is an inclined plane? Like when you are climbing up a ramp. So this is an inclined plane. Okay, this is an inclined plane. ठीक है? This inclined plane is inclined at an angle theta. This is the problem of CBSE. Don't make you do mechanics problem. Now say I have kept a block on it. There is a block on this inclined plane. These are the basics of mechanics. There is a block on this. In physics, we call this a wedge. What do we call it? Wedge. W-E-D-G-E. Aircraft आने से नीचे लगा देता है ना दोनों wheels के नीचे. This is a wedge. Right. This is a block. The block has a mass. So don't you think the block will exert weight? How is the weight exerted? Right from the center of gravity. Weight will always come perpendicularly downwards. कैसे भी रखो. That's why कोई भी object को छोड़ दो वो लटक कैसे नीचे ही आएगा. So have you seen these civil masons who do brickwork? They'll have one instrument. This white thread will be tied, and a conical type of instrument is there. The mistris, when they work, they'll always have that. That is to see leveling. That's called a plumb bob. Whether something is straight or not, they will always hold it, and it will come and settle at one place. ठीक है. How is the reaction of acting? The reaction always acts perpendicular to the surface. So the reaction force is acting in this direction. Okay, reaction force is acting in this direction, right? And there will be a static friction. Friction तो है इसमें. How to find out static friction? We are deviating from work, but I want you to understand how to find out static friction. The way we can understand static friction is friction opposes motion. Given a freeness for this body to fall, which side the body will fall? Towards this side. That means friction should be acting on the opposite side. तो यहाँ पे एक friction force भी है ना? यहाँ पे एक surface पे एक friction force भी है यहाँ पे. This is the force, the friction force. This is the normal reaction. और कोई force है? कोई force नहीं है. And its scenario is like this. See, this is an inclined plane, and I have kept the duster right now. थोड़ा ऐसा रखो तो नहीं गिर रहा है. एक level तक तो नहीं गिरेगा. Okay, I'll use the felt part. Is it inclined or not? Inclined. Still the duster is not falling.
Because the
Friction is holding it.
Yeah.
Let us increase it more. Increase it more. Increase it more. ये अभी just गिरा. ठीक है? That means our static friction just got defeated at that portion. Static friction wins. Friction is limiting always. इसके बाद आप गिरा. Now it is sliding friction. ठीक है? तो our block right now is in equilibrium. Equilibrium means, now see Zoe, you will get a lot of interest here. देखो, equilibrium means net force acting on this should be zero right now. Whatever is, otherwise it should have fallen in either side. अब नहीं गिर रहा है ना, ये वाला सिनारियो है. गिर तो नहीं रहा है ना end of the day. Net force तो zero है इस पे. अब वो डायग्राम हम कैसे देखेंगे? ऐसे देखने से कुछ नहीं समझेंगे. इसको हम मैकेनिक्स में बोलते हैं फ्री बॉडी डायग्राम. फ्री बॉडी डायग्राम मीन्स the entire body is taken free now as a point, as a one point. And in vectors we have the freedom to slide and take away any vector anywhere provided you don't twist the angle. Okay, so let's see what all are the forces acting. Can you tell me, this is now our body, free body diagram. Free the body from all constraints. इसको लेके आओ यहाँ पे और मन में सोचो कितने forces पे act कर रहा है. चलो बोलो. The first force acting on the body is the gravitational force, that is the weight. Weight acts how? Vertically downwards. This is the weight acting on the body. Agreed? What is the next force acting on it?
Reaction force.
The reaction force acting on it. And the reaction force, okay, there is something like, you have to make this inclined plane. So I am just making one inclined plane also in dotted manner. ये सब मजा आएगा आपको पढ़ने में. आ जाओ. Okay. Reaction force is always in which direction? Perpendicular to the surface. So let us make it perpendicular to the surface. Okay. Let's make it perpendicular to the surface. So this is my reaction force. N. Normal reaction. ठीक है? और क्या है? Friction force. Friction is along the horizontal side. ठीक है? तो friction is in this direction. This direction is friction. F. ठीक है? I'm showing this to you just to understand where it helps me, where resolution helps me. Now some more data we will need. Okay, so I am just pulling this further. Now look at this triangle. This angle is theta. Do you agree? What is the value of this angle?
90.
This is 90. What is the value of this angle? 180 minus 90 minus theta. So can I not say this is 90 minus theta? Right. I am interested to find out this particular angle. Okay. This particular angle. Can anybody tell me what is this angle? Again, this is how much? This is also 90. This is also 90. Agreed? Exterior angle is equal to sum of two opposite interior angles. This angle, if you solve out, will also come out as theta. 100% theta आएगा. अब are you able to find out? Okay, नहीं आ रहा है तो ये देखो. Look at this angle. Is this angle? How much is this angle? 90 degree.
Yes.
This is 90. This particular angle is 90. Do you agree?
Yeah.
This is theta.
Yeah.
So what is this angle? 90 minus theta, this angle, this is already 90, then this particular angle I'm saying, this angle, isn't it not theta? Theta. तो बड़ा करके करूं क्या, तो समझ में आएगा, ये थीटा ही होएगा हमेशा, हमेशा थीटा आएगा, ठीक है. सो दैट थीटा मींस नॉर्मल रिएक्शन से जो लाइन यहां पे आया, this angle is theta. Are you getting it? Which was also our wedge ka angle. If you are unable to understand the free body diagram, then understand like this. This was our wedge theta. अब clear हो गया, समझ में आया? Now the job is, imagine that this is your x-axis and this is your y-axis. I can make it थोड़ा खिला दिया, एक ही बात है. Once you are in space and you are on a F-16 aircraft and you're on the cockpit, what is x-axis, what is y-axis? You rotate. Do you feel that you are rotating? No, you just feel the world is rotating in front of you. Actually, your aircraft is having a lot of rotation in it. So, ये x-axis, y-axis समझ में आ गया? If I am to be in equilibrium, right now I am in equilibrium. Come whatever is happening, my net force on x must be 0. My net force on y must be 0. There may be lot of forces acting on me. Out here, your heart doesn't agree. Sir, on X we have an unbalanced force, friction, and on this side we have a Y on this side, W on this side. But our block is not falling. That means block should be balanced. Now, how do you balance it? You balance it by the technique of resolution. Now we will resolve our weight. Weight is a force vector है ना? इसको resolve करो. Weight को resolve करेंगे तो एक कंपोनेंट इस साइड आएगा और दूसरा कंपोनेंट लेफ्ट साइड जाएगा. वेरी गुड. दूसरा कंपोनेंट इधर जाएगा. अंडरस्टूड? दिस इज थीटा, दिस इज अलोंग थीटा. सो व्हाट विल आई कॉल इट? W cos theta. And what will I call this as? W sin theta. Again you can see that rectangle is there. rectangle तो आपको अभी भी दिखेगा. ये देखो rectangle तो है. We have just resolved. And now once you have done this, please forget W. Please forget W. We slowly forget W. Understood? अब x-axis का balancing देखो तो x-axis में W sin theta is balancing the friction force Fx. Body in equilibrium. And on y-axis में balancing कैसा है? The normal reaction is being balanced by W cos theta. This is the beauty of resolving. अब आपका satisfied हो गया और your object is not falling.
Sir, I did not understand the last word.
Which
Sign and
this sine and okay. Did you understand how I got sine and cos? I just resolved the W into two components. Okay, let me bring back the W up here. Originally, W was exactly vertically down, right?
So can you explain how you got sin and cos theta?
कभी भी कोई वेक्टर को ऐसे ले लो ना, ये एक वेक्टर है, इसको ऐसे रिजॉल्व कर लो. अब जहां आपको थीटा दिखेगा, अगर यहाँ थीटा दिख रहा है ना, दिस इज अ वेक्टर ए. अगर यहाँ थीटा दिख रहा है तो ये ए cos थीटा होगा. और अगर आपको यहाँ थीटा दिख रहा है तो ये ए cos थीटा होगा. दूसरा वाला ये sin थीटा होगा. सिंपल. जिसके साथ लगा हुआ है वो cos थीटा होता है. नाउ सी वेयर इज आवर थीटा? आवर थीटा इज हियर. दिस इज आवर थीटा. तो थीटा के साइड जो आएगा दैट विल बी नोन एज W cos थीटा. ठीक है? Now look at. This is the original thing that is happening. How many forces we have? The weight, the friction force, and the normal reaction. 3 forces. But your heart says, 3 forces कैसे इसको balance कर रहा है? पर balance तो हो रहा है. Okay, balance तो हो रहा है. 3 forces. Our question is, how does 3 forces balance this particular thing? Balance तो हो रहा है. So, how is it getting balance? That means there are some forces whose components are working. End of the day, if it is to be balanced, its x-axis net should be equal to x-axis में 0 होना पड़ेगा net force, y में 0 होना पड़ेगा. अभी सोचो, this is the equilibrium position. Now suppose I want the duster to roll. increase its weight, then W sin theta will win over friction. इस तरफ आना शुरू हो गया. Why we resolve? That's the reason. Now we'll go back to our work. Have you understood now how to resolve? Any force that you see, you can resolve the force into two components. In this chapter, your mind should be, if your question is given like this, a ball is pulled by a force F and the displacement is along this direction S, no issues. इसमें resolve नहीं करेंगे, F ऐसे ही fit हो रहा है along the direction of force. लेकिन problem क्या है? Force is in this direction, displacement. आप क्या करेंगे? आप फंस गए ना. Now we will resolve one in this component and one this component. This is the component which is causing the displacement. Any vector can be resolved into two components, horizontal, vertical. Force is a vector, force can be resolved into two. And once you have resolved into two components, then search which component is actually causing your motion. That component into displacement. If you are unable to search it, then straight away do F cos theta. Why in the formula we use, why do we use F dot S? We use F dot S because we get Fs cos theta. And what is Fs cos theta? It is F cos theta into S, and this is nothing but this particular component. So they have made your life easier out here. Are you getting it? Shall we go back and see once again? Now let's see the... If you want anything to be in equilibrium, this thing is in equilibrium. Net force acting on it should be zero, right? Otherwise this will be moving. So net force means what? Force on the x-axis. इधर खींच रहा है कोई तो इधर भी खींच रहा है. इधर हो गया, इधर का सुलट गया. अभी ऊपर नीचे का भी सुलटा देते हैं. हो गया बस. Look at the best is that look at the camera. Is it not the resultant of two cable ties on two direction? How is the camera? There is some science there also. देखो नीचे पे एक सपोर्ट है, ऊपर एक सपोर्ट है, ऊपर को फिर दो साइड में खींचा है. Write down the net resultant on this camera. You just think, take a plier and chop off one of the cable tie of this. Immediately camera हिल जाएगा. Because you have disturbed the equilibrium. Equilibrium means you are at rest. Static. Equilibrium can be two types, static and dynamic. Static equilibrium means you do not move. I push your head this side and I push your head this side. Your face may have expressions, but you will not move. अब नहीं move कर रहे हो ना. Equilibrium है. दोनों साइड से बांध देते हैं ना हम चीजों को. Let this door closer be there. Right? You try to. What does the door closer do? If you open it this side, it stops in this side. You hold it by the other way. हो जाएगा ना. The door will be at equilibrium. Does that mean that forces acting on it are zero? No, forces are acting on it. Net force on it is zero. Net force on it is zero. That's why this duster is, there are three forces acting on this duster, but the net force on the duster is zero. Resultant. And to bring that concept of net force, we have to break some force into the components. And we broke the weight into the two components. And we satisfied the criteria. Clear now? Let's now go back to work again, okay? This was the idea of why we resolve forces. Now, automatically all the equations and problems will come correct. The book will tell you if force is acting perpendicularly, work done is zero. Okay. अभी देखो कैसे मजेदार आएगा. Okay. Two things I'll tell you. The values once again. Cos of 0, sin 0, 0, cos 0, 1. Cos of 90 is equal to 0. ये दो याद रखना. और अभी फिलहाल cos of 180 degree is equal to negative 1. Just remember these three. The book tells us that if you have force and displacement acting at 90 degree, work done is zero. लिखने का कोई जरूरत नहीं है, समझो पहले. We'll spend a lot of time on this chapter. The book tells us that if force is perpendicular to displacement, the book tells me that work done should be equal to 0. In CBSE, they will show all these three criteria. I am starting with this because it is something interesting. ठीक है? फिर एग्जाम्पल तो देना ही पड़ेगा, बिना एग्जाम्पल के तो होगा ही नहीं. सो वेयर आर वी नाउ? वी आर नाउ एट न्यू दिल्ली रेलवे स्टेशन. ठीक है, हमें क्या करना है? राजधानी पकड़ना है. राजधानी ट्रेन वी हैव टू कैच. So, and we have all these girls with us. The problem with them is they can't travel light. They have a lot of luggage with them. So we have hired a porter. We have hired a porter, and the porter is carrying our suitcases. Right? Physics samjho. He's carrying our suitcases. And somehow he managed to take our suitcases all, and he makes us reach our train's compartment. And then he says, हाँ पहुंचा दिए. हाँ मैडम जी पैसा दीजिए. हम बोलेंगे पैसा नहीं देंगे तुमको. हैं? अरे कैसे साहब, मैं गरीब आदमी का पैसा नहीं दे रहा हूँ, आपने काम ही नहीं किया. अरे इतना दूर सामान लेके आए, काम नहीं किया. काम नहीं किया ना. कौन बताया काम नहीं किया? हमने तो सर है जयदीप दास, वो बोलते हैं आपने काम नहीं किया है. कैसे काम नहीं किया है? नहीं आपका वर्क डन 0 है. ऐसा कैसे? तो आप पोर्टर को समझाना शुरू करते हैं. पोर्टर साहब आप अपना फ्री बॉडी डायग्राम देखो. आपका वेट कहां से एक्ट कर रहा है? ऊपर से नीचे एक्ट कर रहा है ना? राइट? दिस इज द फोर्स. द फोर्स इज नथिंग बट द वेट. द वेट इज नथिंग बट द मास इनटू ग्रेविटी. करेक्ट? और ये भाई साहब जा किस तरफ रहा है? हमारे बोगी की तरफ जा रहा है, इस तरफ जा रहा है. ये डिस्प्लेसमेंट वेक्टर है. दोनों के बीच में एंगल कितना है? 90 डिग्री. आप बोलते हो पोर्टर भैया वर्क डन बाय यू इज गिवन बाय F डॉट S which is equal to modulus of F into modulus of S into cos of theta. आपके केस में जाहिर सी बात है F तो है. अच्छा इतना सामान उठाए, हाँ सर mg हो गया. ये फोर्स इज वेट इज इक्वल टू mg. क्लियर? आप बहुत दूर चले हैं, जाहिर सी बात है, लेकिन आपका एंगल 90 डिग्री है ना. 0 है. वर्क डन इज 0 एंड आई एम नॉट जोकिंग, इट्स 0. ये आपका बुक जो है ना ऐसे एक स्टेटमेंट लिख देगा दैट फोर्स when it is perpendicular to displacement work is 0. Don't you think this is a beautiful way to understand with the vector formula? That's why the work done is equal to 0. Can you understand? Now how easily it comes to you. 3 cases from your book we will discuss. This is a classic case. Work done is 0. Force into displacement. Even if you are having a circular motion, ऐसा circular motion है ना, right? Circular motion में क्या कर रहे हो? ऐसे पकड़ के घूमते ना, घूमर 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 डांस कर रहे हो. So how is the घूमर dance? Everyone is being pulled inward. The force is acting in this direction. Otherwise, you won't be in circle. And how is the motion? The motion is always tangentially to this. मतलब यहाँ पे अगर आपको मैं छोड़ दूं ना, घूमर घूमर करते टक करके छोड़ कर छटाक से टेंजेंट की तरह गिरोगे. What is the angle?
90.
Work done?
0.
थकान आना ही नहीं चाहिए आपको. Whenever force is making perpendicular relationship with the displacement, and this comes with our formula. That's why I said you need not mug up. It comes from the vector formula straight away. Now let's see the first way that we started our story with, our first example, okay? And now we come back to, after 3 episodes, we come back to the same story. Force. Which side is displacement? Same side is displacement. What is work done? F S cos theta. What is the value of theta now? What is the value of theta now? पीटूंगा ना पकड़ के. 180 दिखता है तुमको? 0. 180 होने से ये चीज इस तरह होना पड़ेगा. दोनों का डायरेक्शन नहीं दिख रहा है. 0 का 180 कहां पे होगा? ये 0 है. Fs cos 0. What is the value of cos 0? Work done equal to force into displacement. The basic definition. Now do you get it satisfied? Now let's see another one. A spring, and you have stretched the spring. Right now it is in stretch mode. You stretch hai, spring is stretched. Don't you think the spring is trying to recoil back? When you stretch a spring, the spring is trying to recoil back. So this is the spring force. Fs. Which side is it working? On this side. And which side are you giving your displacement? On this side. X इस side जा रहा है, and the spring force is on this side. Work done by the spring force will be, a book will say work done when force is opposite to displacement is always negative. We don't buy that. We will say work done is again same. The spring force into the displacement x into cos theta. But here theta is 180 degree. What is the value of 180? Minus. ये एग्जाम्पल अच्छा नहीं लगता है, और कुछ चाहिए? फुटबॉल. We have given a kick out here. Action. So the football's action force is on this side. Don't you think the football will face also a frictional force on this side? Okay. Now the displacement is happening in this side. Frictional force is pulling on this side. Work done will always be negative. So if I did not have to teach all this tamjam and I wanted to just get you gulped, then force work is said to be the product of force and displacement. If force is along displacement, work done is Fs. If force is perpendicular, work done is 0. If force is opposite to displacement, then work done is negative. How these happened, you never understood. Why this happened, you never understood. Now is the time to do a complete recap. We'll do a complete recap now. 15 minutes है, एकदम शुरू से जैसे पढ़ा था उसको recap. पर ये सारे stories आपको समझ में आए कि नहीं वो बोलो. This one did you understand? ये work done 0 है. Work done in pushing the wall. What is work done in pushing the wall? Why? There is no displacement. Then how do we build up biceps by doing push-ups? Oh, very good. Oh, muscle, huh? ये है ना, पुशअप मार रहे हो आप पुशअप करते वक्त क्या जमीन हिला क्या? Work done is 0. Why are you sweating then? Why are you sweating? Work done 0 means there is no energy, na? Work is equal to energy. If you are not doing work, you are not shelling out energy. But they say, you know, yo guy, 50 push-ups means so much calories burned. अब कैलोरी कैसे बर्न हुआ? ये 0 तो है वर्क डन. फर्क है. मैं आपको पूछ रहा हूँ, वर्क डन मीन्स वर्क डन ऑन द फ्लोर इज 0, बट वर्क डन ऑन योरसेल्फ इज देयर. यू आर लिफ्टिंग योरसेल्फ अप. हाँ, टेक्निकली yeah, this is the here it is becoming 90 degree. ट्रेन का इसमें वर्क नहीं है. That is your labor and emotional part. Emotional part of work done is there. Physics wise there is no work done. There is no work done. Work cannot be done if force and displacement are at 90 degree to each other, because in 90 degree the dot product is always 0. And when you go to mathematics also, you will find that they'll give you two vectors x and y at 90 degree. What is the dot product? 0. 0. इसीलिए तो work done नहीं हो रहा है. यहाँ पे आप अपने आप को displace कर रहे हो ना. That is work done. Work done on the floor. That's why I'll read my question. Work done in pushing a wall, 0. But you are pushing yourself. काम तो हो रहा है. किस में हो रहा है वो आपको देखना है. On yourself is there, and that's why we are actually able to push. ठीक है? So now, yeah.
What if you're doing a plank?
Which one?
Plank.
हाँ, plank करते वक्त what is the work done? Plank जब आप पेन आ रहा है ना आपको, the body wants to move, your hands do not have the strength, आपको उतना reaction force नहीं है, इसलिए आप छोड़ देते हैं plank में. See, all reaction forces have a limit. You are putting your entire body weight on your elbows on the floor. तो उतना ही रिएक्शन फोर्स आ रहा है इसमें. अब रिएक्शन फोर्स जितना देर बेयर कर सकते हो बेयर कर लिया. जब नहीं आया ठठाक से छोड़ दिया. Then your mobile says किक 1 minute up, let me get up, है ना? चलो ठीक है. अब पूरे चीज को नए सिरे से स्टार्ट से देखते हैं, क्योंकि ये अगर आप नहीं समझते. Now if you read Lakbir Singh and you want to read the truncated part, I have no issues. Because my conscience tells me that I have told you how this thing happens. अब आते हैं starting से. Number 1, work. And this part of the definition notes kindly keep it. Scalar quantity. इसको आप रखोगे, आप सब आंसर कर दोगे. Scalar quantity. Equation is given by scalar product of force and displacement. This is what this is known as scalar product. Scalar product, also known as dot product. And whenever you do a dot product, this outcome will always be a scalar. That's why the unit of work is joule and not Newton meter, not Newton meter. Okay? So work in terms of the magnitude can be said as F into S into cos theta, which means if this is S, so Zoe, we will not take we will take a very generic case, and our generic case is always like this, where F and S will not be in the same plane or in the same line. This is we'll take the complicated case. That's why we put Fs cos theta. In the billiards case, billiard table, what is happening? F is along S. So we take cos S 0. In the Porter case, it is like this. We take 90. In the friction force, it is like this, 180. Okay? So F is 1. And how did we get this? The mathematics says that if A dot B is a dot product, it is equal to modulus of A into modulus of B into cos of theta, where modulus of A in vector language is just written as A. Modulus of A means what is Neha's speed, not velocity. Sir, 2 meter per second. किस तरफ जा रहा है उससे मतलब नहीं है हमको, उसका वैल्यू से मतलब है. ठीक है, ये समझ में आया? Parallelly, we also understood. Nobody will ask you what is cos and all, but you remember cos of an angle theta is always given by adjacent side by hypotenuse. This is number 1. This is number 2. How do you find adjacent and hypotenuse? If this is theta, this is always the opposite side. Hypotenuse remains as hypotenuse. Adjacent is the adjacent side. Okay. So in our diagram, if this is A, this is B, this is C, so it will be AC upon AB. This is cos theta. What they in CBSE they give you the values. वो आपको values दे देता है, पर आप ये values रख लो. Cos of 0 is equal to 1. Cos of 90 is equal to 0. Cos 180 is equal to -1. बीच में 2 और छोड़ दिया. इसके ऊपर problems आते हैं. They usually may give you also cos 30 and cos 60. Cos 30 is root 3 by 2. Cos 60 is half. इतना ले लिया तो एक और ले लो. Cos 45 is 1 upon root 2. ठीक है. Generally problems इन्हीं दो में देगा आपको 30, 60 and explanatory questions may come on these 90, 0 and 1. Explanatory questions come on this. They may ask you, a porter is carrying my luggage from one place to another and physics says that the work done by the porter is 0. Why is work done by the porter 0? The work is done by the porter is 0 because the angle between the force vector and the displacement vector is 90 and cos 90 is equal to 0. Therefore, ठीक है? Then ये 2 हो गया. Number 3, force along displacement. Force along displacement. Okay, now see, everything will become clear. Force is on this side, displacement is also on this side. Therefore, in this case, theta is equal to 0 degree. Since these are vector children, vectors can always be up sliding कर सकते हो. बस rotate करना allowed नहीं. You can bring this vector here also if you want, but you cannot turn it. Theta is equal to 0. Therefore, what is work done? Work done is Fs cos 0. So work done is equal to Fs. Number 4 criteria, force perpendicular to displacement. Force perpendicular to displacement. अभी कैसा होगा? Displacement is in this direction and force is in this direction. अब यहाँ पे थीटा की वैल्यू कितनी हुई? 90 डिग्री. यहाँ थीटा 0 डिग्री. So work done will be equal to Fs cos 90, which is equal to Fs into 0, which is equal to 0. ठीक है, बस यही सवाल पूछेगा सीबीएसई। Which one? Which one, Bitu? Third, which one? Which third one? The first one, force along displacement. Theta is 0, so cos 0 is 1. Na? You don't take 0, Zoe. You take cos of 0. However, sin 0 is 0. Cos 0 is 1. Fifth criteria. Force and displacement are opposite. Means in this case, displacement is along this direction, force is along this direction. So theta will be equal to 180 degree. So what is work done here? Work done is Fs cos 180 degree, which is equal to Fs into -1, or W is equal to negative Fs. Just imagine one thing. Plane. There is a spring on that wall. Look at me. There is a spring on that wall. I have pulled the spring and held it till here. No, I'll not leave it. I've held it till here. Okay? Right now, the spring has not torn apart. That means some force is also holding it on that side. That is the spring force. Right? What is work done by me? Force into displacement. Fs cos 0, because I am pulling in this direction. Fs cos 0. What is work done by the spring? फिट मत करो यार, आप चीज को समझो, आप ध्यान ही नहीं देते हो. There is a spring out here. You have pulled the spring towards your side. Look at from your perspective. What is work done by you? Force is in this direction. Displacement is also in this direction. So it's a case of 0 degree. Work done is F into X or F into S. I am holding it right now. Look at from the spring side. Spring के side से देखो. Force इस side है, displacement उस side है. इसके लिए angle कितना हुआ? Negative 180 degree. So cos of 180 is -1. Work done by this is how much? Negative fx. अभी भी आपके दिमाग में वो नहीं आ रहा है. Right now when I have held it here, is it in equilibrium? Yes. At equilibrium all forces acting should be 0. तो इस साइड में कितना वर्क हो रहा है? fx. उस साइड में कितना हो रहा है? नेगेटिव fx. इसीलिए खड़ा है यहाँ पे. अगर मैं हल्का धीरे कर दूं, स्प्रिंग विंस द बैटल, इट गोज दिस साइड. जोर से खींचो, आई विन द बैटल. इक्विलिब्रियम डिस्टर्ब होता है कि नहीं? So what you should know by now, definition of work. Work is said to be done when the point of application of force moves along the direction of force. So when you say along the direction of force, whenever you see that force and work are not in the same direction, don't immediately say that work is not being done. Work is being done. At that time, you should resolve the force. Take that component of force which is along the direction. Now again going back, we say that when this particular toy was pulled in this direction, apparently it makes us feel that F is not in the direction of S, but no, there is a component of F which is known as F cos theta, which is in the direction of S, and a mini component called F sin theta also in this direction. And this is the one which is causing all these problems. See, they were all brought down in the same direction, Sin theta इसमें इतना जरूरत नहीं पड़ता है. In fact, there are many other things also. Say, you know why this cos 90 became 0? A question should come ना, sir, why is cos 90 0? देखिए उसको cos 90 क्यों 0 होता है? 2 मिनट देख लो. ये हो गया, कॉपी किया. मैथमेटिक्स देखते हैं. Why is cos 90 0? थोड़ा इमेजिनेशन चाहिए. हाँ, imagination. Let's take a right angle triangle in this manner. If you don't pay attention from first word, आपको समझ में नहीं आएगा. This is theta. ठीक है? Imagine now, as theta tends to 90 degree. Means what? Means what? As theta tends to 90 degree, C को देखो, C कहाँ आ रहा है? C is slowly coming, यहाँ पे आ जाता है. C यहाँ पे आ जाता है. As theta tends to 90 degree, what about B? This thing is shifting this side. BC is shifting this side. B coincides with A. This is your imagination. इसको अगर मैं ऐसे खोलूंगा, imagine that there are rails on this one. This thing starts sliding, na? Imagine if you try to open it up to 90, don't you think this इसको लेके आना पड़ेगा ना, ऐसे आ जाएगा ना? B coincides with A. As theta tends to 90, B coincides with A. That means AB is lost. You don't have AB anymore. That means AB becomes equal to 0. Now let us look at what is cos theta. Adjacent side AB divided by hypotenuse AC. 0 by AC. So this is equal to 0 when theta tends to 90 degree. These all you learn in grade 10. But imagination is nothing difficult. Socho. You are trying to make it. Now next question is, why is cos 0 equal to 1? Why is cos 0 equal to 1? Cos 0 means C touches with B. That means AC and AB become equal in length. AC and AB become equal in length. 1. So it is 1. समझ आया? बड़े हो रहे हो, बड़ा चीज पढ़ना है धीरे धीरे. 30 and 45 if you want to. अच्छा, बहुत जोश है. No issues. Let's see 30 and 45. Excellent question. Let's see 30, 45. Quickly. 30 देखना है? या जिसमें भी जाना, खाली अंदर स्विच ये है. 30 देखते हैं. How to bring 30? एक इक्विलेटरल ट्रायंगल जोई. 60, 60, 60. Agreed? Take the perpendicular bisector here. This is A, this is A. Now this becomes A by 2, A by 2. I hope in equilateral triangle you know that the sides are always bisector. Now this is 90 degree. Agreed? Now forget about this part of the triangle. This is now 30, 60, 90. Agreed? This is A by 2. What should the value of this? This value should be root of A square minus A square by 4. So this is 4A square minus A square. This is 3A square. That means A root 3, A by 2 root 3 will be the value. Check करके देख लो. 4A square minus A square is 3A square by 4. If you take the root of 3A square by 4, it is root 3 by 2A. क्या हो गया? Mathematics fast कर. 3A square by 4. इसका रूट लो ना. 4 का रूट क्या है? 2. A का स्क्वायर का रूट A. 3 रह गया. ठीक है? Agreed? So, Madam Zoe, you had the choice to make this one, right? So this is opposite. This is height. Which is adjacent? This is adjacent, right? A, B, C. Now you want to find cos 30. So cos 30 is adjacent is what? AB divided by AC. What is the value of AB? A by 2 root 3. And what is the value of this? A. Root 3 by 2. नहीं तो था. Got it. Cos 45 is 1 by root 2. Sorry, I just lost my mind. This is 90. If you take any angle as 45 degree, don't you think better this also should be 45 degree? So it's isosceles triangle. This is A, this is A. So what should be the value of this? A square plus A square, root of A square plus A square. So this should be A root 2. Agreed? Pythagoras theorem. Now take cos 45. Any side you can take. Cos 45. If you are taking this one, then this is the adjacent side. A divided by the hypotenuse. A root 2. A cut gaya 1 by root 2. Okay? Even if you forget formulas, if your basic is correct, you can generate formulas. ये चैप्टर थोड़ा आराम से पढ़ो, क्योंकि ये आपको 11 में नहीं तो तकलीफ होगा, ये सब 10 में कुछ भी नहीं है, ठीक है? And don't worry, again in the next class we will do a little bit of previous and then we solve problem. We'll solve problems from HC Verma. आप आराम से solve करोगे, बस ये concept clear रखो, work is fs cos theta, ठीक है? Right. Next class we'll do mathematics as usual. We'll start our new chapter and then we catch up. हाँ, quadrilaterals करना है ना?